Okay, so far this week we have talked about monohybrid crosses, okay? So now we're going to kick up our Punnett squares a notch and pick up from where we left off. So the principle of independent assortment states how the chromosomes lined up, right? We talked about that a little bit when we were playing Quizlet Live, yeah. Okay, so Mendel needed to answer one more question. When alleles are being segregated during gamete formation, does the segregation of one pair of alleles have any effect on the segregation of a different pair of alleles? In other words, does the gene that determines if a pea plant is tall or dwarf have any effect on the gene for seed color? Mendel designed a second set of experiments to follow two different genes as they passed from parent to offspring, and this is known as a two-factor or dihybrid cross. So one parent had peas that were round and yellow, and the other parent had peas that were wrinkled and green. The round and yellow traits were dominant. So first, Mendel crossed true breeding parents. Round yellow peas times wrinkled green peas. Just like so. Okay? So the two genes that we're looking at is round versus wrinkled is the first, okay? And then the second part of this is yellow versus green. That's our second trait. All right? So when he did this cross, he found that all F1 offspring had round yellow peas, okay, which would make sense. If round and yellow are dominant, what is the genotype of all the F1 offspring? Okay, so let's look. It should be R, R, Y, Y. Big R, little r, big Y, little y. Okay, how do we know this? Without doing a Punnett square, you can just match them up, right? So this R would go with that R, this R could go with this R, Y, and Y. All right? So next, Mendel allowed these F1 offspring to self-pollinate, all right? So when the first generation was allowed to self-pollinate, which is our hybrids, okay, it resulted in the production of 556 seeds. Out of those seeds, he found that 315 were round and yellow, 105 were round and green, 104 were wrinkled and yellow, and 32 were wrinkled and green. This meant that the alleles for seed shape had segregated independently of the alleles for seed color. The alleles for one gene had no effect on the alleles of another trait. This is known as independent assortment. So just because you're tall doesn't mean you can't have blue eyes. Just because in these pea plants they had a round seed didn't mean it had to be yellow or it had to be green. Okay? There's two different options working independently of each other. So the principle of independent assortment states that when gametes are formed, the alleles of a gene for one trait segregate independently of the alleles of a gene for another trait. And this was one of Mendel's three principles. So let's look at a Punnett square for a two-factor or dihybrid cross. When two traits are being considered, the Punnett square will need 16 squares, okay? Each parent will pass one allele of each gene pair to the offspring. Given the following parental genotypes, what alleles could each parent pass off to their offspring? If the parent was A, little a, big B, little b. So you can kind of think of this in math as foiling, okay? So we know this A can go with this big B, or this A could go with this little b, and Vice versa, this little a could go with the big B, and this little a could go with the little b. All right? First, inner, outer, last, that kind of thing. If the parent was big A, little b, little b. Now we know, right? This big A can go with the little b. Big A could go with this little b. The little a can go with this little b, and this little a can go with this little b. What if the parent was little a, big B, little b? And what if the parent was big A, big B, big B? So we can see here, just like I was showing you that little like foiling method, big A, big B, big A, little b, little a, big B, little a, little b. Okay? And so on and so forth. Just to show one more time that the factoring method, let's say for this one, we got these answers because this little a can go with the big B, which gives you this one. This little a can also go with the little b, which gives you the second option. The second little a, I'll go like this, can go with the big B. So that gives us our third option. And our little a can also go with this little b for our fourth option. And that's how we get the different combination of alleles to use in our Punnett squares. Oops. So use the following Punnett squares to illustrate Mendel's experiments. So a true breeding round and yellow times a true breeding wrinkled and green. So we know that round and yellow are dominant, okay? So round will be capital R, yellow will be capital Y, and true breeding wrinkled and green, since these are recessive, will be little r and little y. Okay, so it's true breeding. It's homozygous, whatever it is. So in this case, what is the genotype of each parent? Knowing that they're homozygous, because they're true breeding, you should know that parent number 1 for true breeding round and yellow is capital R, capital R, capital Y, capital Y. And the true breeding recessive should be little r, little y, little y. What allele combinations can be passed to the offspring? So this is when we do our little FOIL method, okay? So this big R can go with this big Y. That's where we get that one. Then we know that this big R can also go to this big Y. So there's our second one that would go up here, RY. Then we know this second R can go with this big Y, RY. And last but not least, we have our second R with our other big Y, RY. So that gives you all the allele combinations from parent number 1. Now you have to do the same thing for the second parent. So this big R, or this little R can go with this little y, RY. This little R can also go with the other little y, RY. Second little R can go with the first y, oops, like that. Little R, let's make that a little r. Little r, y, and the second R can go with the last little y for R, Y. Okay, so that's where we're getting these allele combinations. So here we can see on the screen that this is what we came up with. All right, So those are the allele combinations that can be passed to the offspring. Now we do our drag and drop method, okay? So we can see here the first box gives us R, Y, R, Y. Just so you know, you always put the capital letter first, just like in a sentence. That's why it's written like this. So our next one would be R, Y, bring over the R, bring over the little y. All right, and we keep filling these in just like this. And guess what we get for every single one? Okay, so all the genotypes are the same. 16 out of 16 are big R, big Y, little y. And all of them show up as round and yellow because that's the dominant trait. If the offspring from that cross, or the hybrids, are allowed to self-pollinate, round and yellow times round and yellow, what is the genotype of each parent? Since we know there are hybrids, okay, you should know from the last Punnett square we just did, the genotypes are big R, big Y, little y. So now we set up our 16 squares again, and we figure out what are the possible allele combinations from each parent. So I'm going to show you this one more time, and then I'll stop doing it over and over. So we FOIL. First one's like that, so big R, big Y, big R, these are the outer, big R, little y, inner, little r, big Y, last, little r, little y. Okay, and then you'll do the same thing for this parent. So pause the video and try and figure out what would go on this side of the Punnett square, just to see if you can get it right. So we already know this is going to look like this, and the other side, if you tried it, should look like capital R, capital Y, capital R, little y, little r, capital Y, little r, little y. So now we drag and drop, okay? So here's what our results look like if you drag and drop them properly. So you can compare what you got to this dihybrid cross. And now we can look for different genotypes and different phenotypes. So we have 1 out of 16 is big R, big Y, big Y. 2 out of 16, so we can see this was 1. Here's our 1. Our 2 that are the same are big R, big Y, little y. Then you get 1, so if you're following the pattern, you get 1 that is big R, little y, so there's that one. Then you can see what's going to come next. Big R, little r, y, these two, okay? So 4/16 are R, 2/16 are big R, big Y, 4/16 big R, big Y, little y, 2/16 and 1/16, okay? And 2/16 of that. And last but not least, our 1/16 that is all recessive, that's right here. That's this one, all right? So then we can look at the phenotypes for this. The phenotypes, what is R, big Y, big Y? Oh, here's the pattern so you can list the genotypes, all right? So you do 1, then there's 2, then there's 1, and you go down the list like this. 1, 2, 3, 4, 1, 2, 1, 1, 2, 1. Okay? So the phenotypes are 9/16 of them are round and yellow, 3/16 are round and green, 3/16 are wrinkled and yellow, and 1/16 is wrinkled and green. So a practice problem. Right-handedness, all right, is dominant over left-handedness. The ability to roll your tongue is dominant over the inability to roll your tongue. What offspring might be expected from a cross involving the following parents? So take a minute, really try to pause the video and fill out this whole chart and the genotypes and phenotypes and see what you get. Then you can always go back and fix your answer after I show you the answer, okay? So just pause it right now and give it a shot. All right, hopefully you ended up with these as your parental alleles using that little foil technique or distributing technique. And then when you drag and drop, you got these as the offspring possibilities. Okay, so now remember we can cross them off diagonally to use that genotype thing. So 8/16 are these, and 8/16 are these, okay? So if you look, you can see pretty easily how that all worked out. So half of them are right-handed and tongue rollers, and half of them are right-handed and non-tongue rollers. Here's another practice problem. A woman who is right-handed and a tongue roller has a father who is left-handed and cannot roll his tongue. She marries a heterozygous right-handed tongue-rolling man. What possible offspring might they expect? So what is the genotype of the woman? The woman is right-handed and a tongue roller whose father is left-handed and cannot roll his tongue. So she has to be heterozygous. All right? Because she's dominant, but she must have gotten the dominant side from her mother. She marries a heterozygous right-handed tongue-rolling man. What possible offspring might you expect? So what is the genotype of the man? Once you have those figured out, they're both heterozygous, then you should be able to come up with your allele possibilities and fill in your Punnett square. So pause this video and try it. All right, so your possible allele combinations should look something like this if you did it right, so check your work. And the genotypes, okay, are going to follow that diagonal rule because it's two heterozygous ones, okay? So this pattern works when you have two heterozygous. Just like that. So those are what the numbers look like. And phenotype, oh, here we go. It's doing the cross out for you. So the next one's 2. If you notice, it matches these numbers right here, okay? So now there's 2 of those. Now there's 4. 1, 2, 3, 4. Then there's 2. 1, 2, 1. 1, 2, and 1. So your phenotypes come out 9/16 right-handed tongue rollers, 3/16 right-handed non-rollers, 3/16 left-handed tongue rollers, and 1/16 left-handed non-roller. So, summary of Mendel's principles. We're almost done, you guys. Mendel's principles form the basis of modern genetics. His principles include that the inheritance of traits is determined by individual units known as genes. Each gene is passed from parent to offspring. Each gene has 2 or more forms called alleles. Some alleles are dominant, while other alleles are, very good, recessive. Each parent has 2, that should be a 2, has 2 alleles for a particular trait that they inherited from their offspring. They will pass 1 allele to their offspring when the alleles are segregated into gametes. And last but not least, the alleles for one trait segregate independently of the other alleles. Sorry, let me go back to that screen. Yet again, my computer is being slow, so I apologize. All right, we're going to say this is the end of the notes, and I want you to try the couple practice problems in Google Classroom and make sure that they are submitted by the end of the period. All right, your scores will count on that, so make sure you get it done.